Hello, this is Dr. Ali Reza Manashti, and I am going to start Chapter 1 for the Introduction to Data Science course. The objectives of this course is to define big data, describe the role of a data scientist, and identify different steps of becoming a data scientist and using the data science process. Um, for this course, you need to have a project. I will give you more information about that, but for now, you must think about a project that involves at least one of the following components. So, your project should be either a data science problem that is going to be solved at university or a business. That means a local business, a business that you go and find a data science problem directly by yourself and then try to address their problem, get access to their data, and then present the results to them. If you find a problem, some database online that is for large companies like Uber or Tesla, that doesn't count as a problem that is going to be solved at university or business. Another option that you have is to create a large web scrape dataset created by yourself. To do this, you and your teammates could go and try to get access to a website and use some tools like Beautiful Soup to libraries like that to create a data set from the websites themselves. Another option for you is to try to find a data set that is quite large, larger than about 100 gigabytes, and try to use that information database to predict or train your model. This will give you some challenges that you may require to choose a different your different options for storing that data or some options for processing that data. So all in all, that is an option that you have. Finally, your final option, another option that you have is going to fully develop an operational cloud or app. In this way, you focus on creating, maybe using a simpler model, a data science model, or a prediction model. But your main task would be to deploy that model into cloud, and in a way that we could, an end user could go and use that website or app. It should be a full functional website, and the information, everything should be related to your model. Don't forget that for any other solutions that you choose, you may need to have a delivery method of using a simple website. The difference between this option and the other option is that there's more emphasis on the website and app, and it should be fully operational. For the other ones, a prototype is enough. For those who only focus on a model and try to develop an app that is going to be used by the end users, you should focus more on the functionalities of your app. The last but not the least option for your project is to choose a project and based on a paper that is published recently into 2019 or 2020 conference paper in top tier conferences such as NeurIPS, which was previously called NIPS, ICML, etc., or high impact factor journals. So journals that have a high impact factor or IF of, I don't know, more than one or two, those are going to be considered high impact factor journals. And what you could do, try to choose a paper that has potentially some code on GitHub, or if they have something interested and simple that you could develop, and try to start with that and try to build on top of that and use that model for another purpose on another data set that is not used by the others themselves. In that case, you learn how to use the state-of-the-art models and use data processing techniques to get access to different data sets and use them for your project. So for now, you may need to write a proposal. So your proposal, there are some components of your proposal, including the team members. You can have teams of up to 3. you can be an individual. The normal load would be for a team of 2, and then another option is for you to have a team of 3 students. So then write your project proposal. It should be you should provide enough information regarding your data source, where your data source would be, how you're going to choose your model, and what you're planning to do, and submit it as a report. Remember that you need to present your presentation as well, so your proposal as well. So that is another thing that you should consider. So for your proposal, I need report and set of slides, which would be your presentation. Then you can build upon that proposal and use that report, and also use that presentation file to complete full presentation for your final report, final project report, and presentation at the end of the course. So whatever time you put into your proposal is not going to be wasted, and it will be used for your final report as well. There is a chance that you may choose something that is not related to data science. So make sure that you try to communicate your ideas with me earlier, or if you write your proposal, think about other options as well. There has been a few cases that I had to ask the students to choose another topic because of the some of the main issues that they were facing. So one main problem that everyone were dealing with is novelty. So your proposal should be novel. It should be a new idea that has not been tried before. At least there shouldn't be any code online. There shouldn't I prefer you to choose a data set that for an application that hasn't been tried on it before. So if everyone uses MNIST data sets, for you to go and try to run MNIST data set, like load MNIST data set and do some classification on that, is not going to be a novel idea. So make sure you're choosing a novel idea. And also, if you're using any of these options, like a large web scrape data set, make sure you identify your data sets beforehand as well. So like look at the website, think about how you want to get data from it. You need to have data sources in your proposal. So if you propose something, I expect at least a few pages, like 2-3 pages, that describes your data set. Where is it located? How many samples do you have? So these are all information that I want to be provided in your proposal. And what is the question that you want to answer? That is your research question. That is also an important part of your proposal. So if you choose something that is novel, and if you have identified your data source correctly, so then I think most of the issues are resolved. Yeah, if you have a team of 3, you may want to make sure that you choose more than one of these options for your project. And the most important thing for you to do is to write a report that can be published. So that is going to be a very important factor for you. So for research-based students, I strongly encourage you to choose this track, which enables you to write a report that could be used in a conference or journal. So let's begin. Let's begin talking about data science. What are your thoughts on big data? How do you define big data? I want you to think about it and let me know about your thoughts. You could either comment below the video if you're watching it in YouTube, or just filling in the information using the information tools that are provided to you in your courses. So Um, I want you to think about this. Is there a threshold at which data becomes big data? How do you really define it? Is, for example, if a file that fits into my computer uh, small data, and if it doesn't fit into my computer, it's big data? Um, if I've got a hard drive which is 2 terabytes and I can store some movies in it, that's not considered big data. But if I've got, um, I don't know, like a collection of big Blu-ray movies that are going to need hundreds of terabytes, that could be big data. How do you define it? Do you have any personal experience you want to share about how you define big data? Uh, so usually when we're in class, we're discussing with like your friends, people around you in class. But yeah, if you've got someone around, like ask them how they define big data. Um, or recently, are you using any new tool or novel analytical techniques to handle big data? For example, you may have started downloading some files for research or for a course that was too big to open in Notepad or Excel or any of those tools. Um, have you worked as a co-op student or as an intern or as an employee in some company and they were using something else other than regular tools for data processing? Share that with us. Tell us if you know any tools or techniques to handle big data. What is big data? So we usually define big data as data sets so large that they break traditional IT infrastructures. So these data sets usually change, like the sizes change over the time. What we call big data in 2020 is different from what we were going to call big data in 2030. So in year 2000, for example, big data could be a file that was 1 gigabyte. Right now, big data could be something that is 1 petabyte. So this definition of big data is going to last for a long time. So if there are some traditional IT infrastructures that are going to break and you cannot use it, then we could say that the data is considered somehow big data. One good example of that is that some of you may have experienced that you tried to open a file in Excel and looked at the data and Excel could not load it. Or you wanted to open a very large XML file in Notepad and your computer froze. So those are some examples of some of the types of data that we could call big data. Big data has three main characteristics. Some people add one or two or more and say we've got more characteristics of big data. But the main ones are volume, velocity, and variety. Some people add value as another one, but these are the main characteristics from an engineering point of view. So volume, big data is huge, it's large in terms of volume. Velocity, big data is generated quite fast. So if you consider some social media networks, you'll see how many photos and videos are generated at each second. So that's velocity. And the size of them are quite large. So the videos are 4K or Full HD, and that volume is quite large as well. So those are the two characteristics, and the third one is variety. So big data is not just structured data, it's variety of different formats of data. Examples of those, we can think about it. What are some examples of data variety? The data could be in text format, in binary format. Images are data as well. videos, text messages, social media data. So this variation in different data sets is the major source of the problems that we have with big data. So if you want to think about some examples of big data, I'm sure you can think of some, but some main examples of big data are, for example, in communication and media entertainment. Think about all the music and videos that is uploaded to YouTube, social networks, all that. In financial services, the transaction data, all the bank information, like all the transactions that are happening. Think about Bitcoin transactions, stock market transactions, everything that is being recorded in real time. Those are some sources of big data. In healthcare, think about your smartwatch or your phone that tracks everything that you do. Think about how much information is collected when you are among, I don't know, hundreds of millions of people that have data being recorded every second. And then we have social media. So social media is a huge source of big data nowadays. From Twitter to Facebook, LinkedIn. LinkedIn, for example, these days when I go there, there's so many posts and information, notifications, people that wanted to follow me, that they like my post, things like that, and also on Instagram, all these places. Just you can't imagine that, right? If you miss your social media for like 5 days and you go there and check everything, you can't even scroll down maybe to finish all the new posts and comments and read them all. And this is just for one person. Imagine the content of billions of people around the world that is being shared simultaneously. Internet of Things, IoT, is another big source of data. Think about all these Tesla cars, all your phones, every time they're connected to internet, your GPS signal, cameras, thermostats, I don't know, like this smart speakers, Siri, Alexa, Google Home. So they are all sources of big data. So we have these sources all around us. And the main problem that we have is that 80% of the big data is unstructured. So what that means is that most of the data that we have is either text documents, images, and videos. Of course, you can add audio, and nowadays we've got different sources like, I don't know if they count differently, but virtual reality, videos or images, sensor data, I don't know. Those are all kind of, they add some dimension to the regular videos and audios that we have. So that is the main source of the data, 80% of the data that we have. And there are different types of data that we know of. If you take a look at the structure of the data itself, the data that we know as like regular spreadsheets or regular formats, they're simply structured data. So if you have, I don't know, some data that are in relational databases like SQL databases, MySQL, MS SQL, and if there's some data in the CSV files, those are all structured, well-defined data. but not all data is like that. That is the list of all our problems. So when you want to talk about big data and you want to dig more, you will see that there are some semi-structured data that they're not as structured as structured data, but it's not as easy to use them. So if you have a textual data files like with patterns that you could kind of identify, then that is semi-structured data. XML files are one type of that information. When you go and try to get some information from either a website, if you want to try to web scrape some data from the internet, and the definition of that is that you don't go and get access to a data set itself. You go and look at a website, try to create a crawler or create something like that goes to different parts of that website. And what it does is that it tries to access the data they're trying to find a structure in the HTML files, and then tries to extract some structured data out of it. So HTML files could be data that is that looks like that as well. So sometimes that goes into the quasi-structured data kind of category. So if they have some erratic data formats, or they are formatted with some tool, and you may have, for example, some time added at the end of it, something similar to log data. If you have any log data that you create out of your program, that is quasi-structured data. So web click stream data, the data that you collect when different people come to your website and then click at different stages, that's a kind of a quasi-structured data. And of course, the unstructured data is the data that has no inherent structure. So an image. What is in an image? Like, if I send you an image, it's just zeros and ones. Humans understand images, but machines usually don't. So in an image, if you see a child that is holding a balloon, and there is someone trying to kidnap the child with the balloon, you may see that information by looking at these, colors and shapes and everything using your mind. But a computer has no idea what's happening and what is in that image, other than seeing that there are some objects maybe in it. And that is actually that ability to identify objects and images and faces and maybe the type of the scene. All that has been added with the help of big data tools such as deep learning in the recent years. So by default, like images, videos, text documents, like all that is considered big data. So I'm talking to you right now, right? And I'm just speaking. So this is audio, this is just signal waves. So these signal waves, they just mean some zeros and ones in a computer. They can't figure out it's not easy for them to figure out what I'm saying, unless they use some tools to transcribe what I'm talking about. And then you need to add some dimension to it. You need to add the fact that, well, I'm using some slides as well, and I'm teaching, and then things start to make sense a little bit for a computer. But if you want to convert that into a format, a structure, I think we're getting there, but we're not there yet. Another important point is that you may want to ask, how significant is big data? How big really it is? This information is a few years old, but consider the fact that, for example, let's look at Walmart. Walmart used to generate 40 petabytes of transactional data. each day. So every day, that's what Walmart generates. A petabyte is 1,000 terabytes. If you want to take a look at it, this is how many bytes it is. So Google, I'm sure it's more now, processes 24 petabytes. So each day, like they're processing petabytes of information, if not thousands of them right now. So each day there are 413 petabytes of data produced by the cameras around the world. So sometimes you think, oh, someone is watching me. All right, someone could watch you, but that's a lot of information if someone is going to, I don't know, watch everyone in the world. It's like crazy. Like you'll understand that soon. Maybe it's targeted. Someone could surveil someone, or like in general, but it takes a little bit more than that. And I'm not saying it's not there, but it's not trivial, at least. So I want you to think about something, okay? And take your time with that. After I ask this question, pause your video and take some time thinking about it. So imagine that you've got a golden opportunity that it's gonna change your life. Someone offers you 1 day worth of Walmart's data, and they give you 24 hours to try to find the structure that you need to actually store that data. So Walmart's data in a single day is around 40 petabytes. That is 40,000 terabytes, right? So, and well, you're at home, you've got some time, you've got 24 hours. And if you could store that information, I think a lot of people will buy it from you for a really good price, because everyone want to know what's happening in Walmart, right? Or if you just get access to that data, you can find a lot of patterns. So I'm sure a lot of people are going to buy that information from you. The only thing you have to do is to store it, okay? And you've got 24 hours. What do you do? Like, how do you prepare 40 terabytes of storage and connect it, make it ready, so that if I bring my laptop, which magically stores all that information in it, then I could give it to you? Think about it. Something that I want to add before, I hope you haven't paused your video, is that think about the space that you need, the cost of it, the connection, the hardware, and the speed required to perform all these tasks. So for costs, try to figure out how much does it cost to get access to that 40 terabytes of storage. How long, what is the space required to actually put them in? The connections, how do you connect these hard drives together? The hardwares that are needed, the speed, what is the speed? Think about it, okay? So I'll just wait for a little while and let you think. Okay, so if you thought about it, you will try to compare that data with what you have in your computer or something similar. So what does it mean, like 40,000 terabytes of data? So for example, I give you an example. My computer, the laptop that I'm using right now, it has around 500 gigabytes of storage. So that's actually half a terabyte. Okay. I've got, like, you could go and try to buy an external hard drive, which is around maybe right now 8 to 10 terabytes. Like you can buy them for around 200. If you get a discount, you can maybe buy them for $200. Okay. So a 10 terabyte for $200. Okay. So how many of those do we need? How many 10 terabyte hard drives do we need? So we've got 40 terabytes. So we divide that by 10. Okay. How many do we need? Okay. So we need around 4,000 10 terabytes hard drive. So, and if you look at the cost of that, at least, like, let's just start with the cost. So that's going to cost us how much? 4,000 times 200, because each 10 terabyte is 200. So that's going to be 8. Okay. So if I'm not wrong, that's going to be $800,000. So first, if you want to get access to that information, you've got to get a mortgage, I guess, and get $800,000 to get those 4,000 hard drives. Okay, and how much space do you need to store those 4,000 hard drives? I'm sure, like, we could find a way to store them, but think about the room that you're in right now. And kind of a hard drive, if these are this is one of these external hard drives, and they've got some maybe cords that you have to find a place to plug them in, right? And then you need to connect a USB hard drive to actually a computer, right? So the data, this is the power, and then there's a data cord that you need to connect. This is just for one. You may have more of these, right? This exercise is quite important because sometimes you underestimate the size of these, and sometimes you overestimate them. So right now you see that only by two of these I can store, first of all, 20 terabytes of hard drive with $400. So if someone comes and tells me that, well, 100 gigabytes of data is too much, I don't know how to store it. Well, it's not that hard, to be honest. Like, you could store it in your computer quite easily. It's not a big challenge. You can download them. I downloaded around 600 gigabytes of a data set in around half a working day, right? From like maybe 1 p.m. to 8 or 9 p.m. One of my students asked that they had trouble downloading, and I downloaded it at home. At university, it takes less time, but again, that's all using free tools. So this is 2 of those 4,000, but if you really think about it, okay, if that is the size of it and we want to store more of those, that is 4, 8, 16, 32, and so on. So I think it's gonna fill your room at least. if you have a decent amount of room and you put a lot of I don't know, like shelves in it, you know, and you could connect all these together quite efficiently, right? So that's going to be a lot of USB hubs. So think about all these connections, all the hardware. How many power bars do you need? You need to power 4,000 plugs. So that's a lot of the hardware as well. And think about the speed now, okay? An average hard drive, if not an SSD, the transfer speed is around 100 to 150 megabytes per second. So 100 megabytes per second is the average speed of a hard drive. So we've got what? We've got 40 terabytes of them, of data to be stored. And if it is sequential, we start getting it sequentially, not in parallel. Then just to get that through our main USB, like imagine that you connect it to my computer and then there's this one connection that you have, or you try to download it from the internet, like you need 1 gigabyte per second, gigabit per second internet, which I think university has this, but I haven't seen it at homes around this area in Regina. It's available in other provinces for home as well, but this is not something you can find quite easily at home these days in Regina. But you need that to be able to download 100 megabytes per second. And you have how much? You've got 40 terabytes, right? So if you want to know how long it takes for you to literally download that amount of information, how can you get that? Let's see. So we've got 40,000 terabytes. So that is around roughly 1,000 gigabytes. And a gigabyte is 1,000 megabytes. So if I divide it by another 0, this is going to tell us how many 100 megabytes per second do we need to get. It's actually, sorry, that's kind of a multiplication. Yep. So 40,000 terabytes times this, it's gonna be 1, 2, 3, 4, 1, 2, 3, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's gonna take this number of seconds. Correct me if I'm wrong, but that's gonna take this number of seconds to transfer this data. So roughly each day is 86,400 seconds. Sometimes I forget, like 4 or 6 could be 84,600 or 86,400 seconds. So assume that this is going to be 10. I'm telling you how to estimate as well. That's why I just don't give you the actual numbers, because estimation is a friend of yours, okay? So this is going to be, so 10 of these in here. So it's gonna be 10 days, 10 or 11, yeah, I guess 12 days for that. It's gonna take 12 days for that part of it, and then 400 times 12 days. That's gonna be 48 days. That's more than, that's around 13 years or so, if I'm not wrong. So each year is 365. So, um, if you can find, again, I may be wrong to some extent, but not total wrong. If you can find 40,000, like not 4,000, if you can find 4,000 hard drives and enough connections in Regina or in Saskatchewan, like you could go to Saskatoon, you could, I don't know, like that's 2-hour drive, Moose Jaw, all around this place. If you know around, how many places do we have? We've got Best Buy, we've got HBL, like some places around. Sometimes they have 1 or 2 hard drive, or you may order them online, you know. Anyways, I don't think Amazon has 4,000 hard drives of 10 terabytes hard drives on stock right now. If you can get all that here and you can connect them, fit them here, and then try to download the data and store it there, it's going to take 13 years with one of the best internet connections to just store that information in your hard drives. 13 years, not 24 hours. So this is one day, just one single day of Walmart's data, that is transactional data that is recorded. And just think about it. That's why big data is really big data, right? So when we talk about big data, it's not just, okay, I've got like 2 terabytes. It takes, I don't know, 2 days to transfer it to your mobile phone, this movie, I don't know, for using Bluetooth or something. No, like we're using our best options and try to get things processed and stored, and it's going to take years. That's why there are a lot of industries, there are a lot of companies, there are a lot of tools, there are a lot of foundations and countries that are trying to create tools that you could store that data and process it. This is a big data and AI landscape in 2018, which is like there are new ones every year. So this guy, Matt Turk, is like creates that. I'm using this for educational purposes. If you look at this huge map, you could search it online and get a copy of it. You will see that maybe one part of it is something like, I'm trying to find Hadoop. Yeah, here. So there are some open source frameworks. Let me show you what this is. There are some open source frameworks that are being used, and there are some data sources and APIs, and the rest of it are maybe big companies that are creating all these tools. So some companies are giving you infrastructure. For example, if you want to store all this information, you don't need to store it on your computer and go and buy some hard drives. You can go and get storage in cloud from AWS, I don't know, Azure, Google Cloud, etc. If you want to process that data, if you want to copy something, if you want to know what's going on, then you can't use your file system. Yeah, that is an interesting point. Another interesting point that I want you to consider: the fact that, like, it's the regular operating systems do not support that. Like, you can't use, I don't know, Windows and try to connect all those hard drives in it. It's just not going to work. You need a kind of a server framework or a tool that can access all data. The framework that enables you to do all that, one famous one is Hadoop. So Hadoop file system, or HDFS, that's Hadoop Distributed File System, is a tool that you can use to store a file that is 40,000 terabytes large. And the way it stores it in kind of a 100 megabyte chunks. So, and if you want to process that data, process that information, that you need to, I don't know, choose your ecosystem, choose any of these tools that are potentially going to work together. If you want a live stream, like your options are Kafka, Spark, Apache Scarf, Storm, all that. If you want to go with machine learning, you need to go with like some tools like TensorFlow, Theano, Microsoft Cognitive Toolkit, Caffe, Keras, etc. So just think about all these tools that are out there, and just realize that it's a much bigger world that you might have imagined. You may go and learn some of these, get certificates in one of them, like spend half a year, try to learn how to use Google Cloud, or how to get certificates in AWS, or get Microsoft certificates in some of these areas. But this is definitely huge, and it needs a teamwork. So have that in mind. So what is happening right now is that all this data enables us to try to think what we could do with that. Imagine we had all this power and capacity to store and analyze this data. What could we do? So data science is a science that will help you predict what's going to happen next based on the data that you have. So it's an emerging interdisciplinary field, and this field is a field that is in the center of computer science and IT, math and stats, and domain and business knowledge. So this is a nice diagram. If you take a look at it, when computer science and IT merge with business knowledge, you have software development. So software development is you try to solve a problem in a business by trying to provide a software and service. So software development is an important part of data science. Also, when you use computer science and IT and try to use mathematics and stats to try to teach machines how to learn from example, then you have this concept of machine learning. So machine learning is actually out there, and it's what you can see between math and computer science. And then you have math and stats and the domain and business knowledge. What this gives you is you can have traditional research, which is about analyzing the past. So, for example, using statistics, you can go and try to find what happened in the last few years in a company in terms of revenue, loss, expenses, human resources, customer acquisition, etc. So that is a very important part of the use case of statistics in a specific business. But when we're talking about data science is about future. It's about predicting what is going to happen as accurately as possible. Sometimes regular linear regression could help solve our problems, or some time series analytics, but usually there's more than that. So there's a difference between the current business intelligence that we have in a company and the data science. So the business intelligence talks about, like, maybe a little bit ahead of time, or if this is the current time, if this is now, then business intelligence is talking about what happened in the past. And the business value of that is limited, because past is past, right? We can't do anything about it. But if we know about the future, so if we know about what is going to happen next, then that is going to give us an edge in our business. And the business value of that really is much higher than business intelligence data. So that is what data science is giving us. Data science is providing us with the knowledge to create tools that enables us to predict what is going to happen in the future. So a lot of people are talking about data science these days. So data scientists are they have like they're one of the coolest jobs of the 21st century. That's where Harvard Business Review talked about it. And the need of the data scientists, which is right now, it was maybe a few years back, or last year, but now we have a lot of data science, and we need a lot of data scientists to analyze data. Look at the world around us, like this, with this pandemic, COVID-19 pandemic. Everyone is creating dashboards, creating tools, looking at the data, what's happening. The data is everywhere. The data is in the news. The politicians, everyone is looking at charts, news, and they talk about the future. What is going to happen in the next few months? What is going to happen in the next year? Right now, a lot of universities are conducting their courses online because they could use data and predict what's going to happen in the future. Maybe there's a second wave, third wave, and so on. So data is everywhere, and a lot of people, unfortunately, were out of job. But usually, a lot of people in the data analysis and data scientists, like data science centers, that are still working very hard. So what are the main skills that a data scientist should have in order to perform his or her job? One of the main skills is a skill set in math and stats. So you should have the data scientist should have a basic understanding of math and stats, and much more than that. So first of all, like, you need to know about populations, how to get access to the data, about sampling, how sampling works, what are the different ways of sampling, and you need to understand the distribution, all that, data distribution, and you need to understand maybe some probabilistics, Bayesian rules, things like that. So there are a lot that you could learn in a little bit amount of time about math and stats. So I definitely recommend you to go and try to build upon that. The first few chapters actually of the 100-page machine learning book is going to bring you up to speed with some math and stat that you may have forgotten from your high school. So that is quite valuable. So programming, a data scientist should be a programmer. It may be a little bit different from software engineer, someone that just writes code every day and tries to create user interfaces or backends or all that. But you need to understand the basics of programming, especially in a statistical software or more general software like Python, R, or Julia, sometimes MATLAB. So these are all these programming languages that are going to help you a lot. By now, you should have got your Python certificate. I hope you enjoyed that training, and you have a basic grasp of Python language, which is going to use. And also, that person should be data savvy. They should understand data, work with data. They know missing values. They can access databases. They know how to use SQL queries or write them, how data sets are generated. And they should also have some knowledge of creating data sets in their sandboxes. Now, these skills are more regarding maybe a communication kind of set of skills, which is also, again, quite important. Like communication is very important. Like I can't say how much I miss that part in different people these days. like you need to communicate with people, tell them what you're doing, ask them questions to do your job, try to make sure that you have all the information that you need, and also help them understand what they need. It's very important as a data scientist to help people understand what they need, because from my experience, it's often very like people do not know what they need, or they don't know what they can do with their data, or they don't know if they have any particular data. And you need to interview with a lot of people. I was working in a company before, and it was an oil company. So in that company, they wanted to do some, they had to find some data regarding reporting to government. And a lot of people were involved in that project, but they couldn't find out how to start getting the data. And every, like most of the times, the managers were talking. So the managers were talking, okay, we should do this, we should do that. So when I went there, they put me on that project, and I started looking for the person who is actually doing those reports by paper every year or every quarter. And and a lot of people were avoiding him or her, but she was the main point of getting access to the data, how to communicate with, how to get access to the main sources of information. And I remember we conducted like a 4-hour interview with her. Like we just listened and listened and listened. Like listening is important. If you want to learn about something and you want to go to a company, try to listen first. Try to wait. Don't tell them, I know this, I know that, I could do this, I could do that. No, just listen. Listen to see what they need. Sometimes when people start talking, they can reveal what they need much better if you just ask them random questions. So let them speak, ask follow-up questions. Those are some of the basic communication skills that you need to have that enable you to find problems. So as part of that communication, you need to understand the basics and all the even more than basics of visualization. So we talk about that, but visualization is an important skill that you need to have. You need to understand how to create diagrams and all that. I shared you a video of some part of that, how you could create really good visualizations from the big picture to graphs to diagrams to charts and even text. So these are all like the way you put text around your visualization, the font, everything that is going to matter. And critical thinking. It's very important for you to be a critical thinker. You should not accept everything that that people tell you. You should try to examine everything first. Maybe there's something wrong happening. Like if, again, the same case, the person that I interviewed with for 4 hours, and she gave me, he or she gave me all the information that I needed. He or she was the person that everyone asked me to avoid because they didn't like to maybe talk to her, and they thought maybe she doesn't understand much. But she was the most knowledgeable person that I've found, and not talking to her was the blocker of all the problems that they had. So you need to be a critical thinker. You need to think out of the box. So make sure that you definitely consider that, and try to improve your skills. Try to see how you could kind of be that type of person if you want to be a data scientist. And soft skills are also like a huge range of soft skills is going to help you as well. So in general, you need to know, be a business person. You need to know how to talk with people, how to understand them, how to listen to them, and make your way through different things, how to write a good email, like all that. and also how to use efficient tools and everything. So in general, these are the main characteristics of a data scientist. Okay, so if it is so hard and it's so complicated, why do we even want to do it? Like, why care about data science? I know it's cool, but it's hard, right? So big companies, actually very big companies, are using data science to make sure that they acquire new customers or reduce customer churn. For example, I don't know, you've heard about Sears. I don't know if you've been around in a few years back. Sears was a big company it was a very famous company, but they mostly only had brick and mortar stores, like physical stores. So Sears had a physical store that sells kind of most of the clothing, a lot of clothing, furniture, all that, and I really liked it. Like, we bought a lot of stuff. We were there shopping all the time. It was like Walmart, but not with grocery. So that was the case, and on the other hand, you have something like Amazon. So Amazon started to give you some odd kind of way of service. They said, well, you want to buy a shoe? Just go and look at it online and buy it. And that's one of the weirdest way of buying a shoe, right? If you want to buy a shoe, you want to feel it, right? You want to feel it, you want to try it, the size, everything. But they said, well, no, we're going to do it online. So Sears continued what they were doing, and Amazon continued what they were doing. And look at it now. Within a few years, Sears started to lose customers, but they kind of maybe didn't see it or didn't want to try to build an online business, or they couldn't compete with Amazon.ca. So they lost most of their customers. They couldn't keep up with their delivery, and eventually they had to close. So a lot of branches all over the Canada were closed. But Amazon right now is shining even more than before. Like in the past few months, I think the stock went up from around 1,800 to 2,600. That's like I don't know, 30-40% just within a few months. Why? Because now everyone see that need of getting access to everything delivered to them, which is easy, which is safer, which is somehow, to some extent, it feels like it's better. And Amazon is still doing its way. Why is Amazon successful? Because it has been doing all the resources that it could get to retain their customers and acquire new ones. So again, this image, look at this. This is not in Amazon. This is in Instagram. So in Instagram, sometimes you go and search for something, or like in Google, somewhere like that. You say, well, a sneaker, and what are good sneakers? Then you go and browse your Instagram, and you see a lot of different sneakers. The way that you were looking for are there as an advertisement. You see, this is a sponsored one. And then you click on it. You say, oh, maybe this is what I'm looking for. And then it not only shows you that a specific sneaker, in this case about buying a book, it tells you what customers also bought. So that if you buy one item, you probably buy the similar items as well, or it's going to help you. So how does it know which customers bought what? Because similar to Walmart, you see that petabytes of information. Amazon has the same amount, if not more, of data that they process, that they actually store and process. It's not going to take them 13 years to process. They use all those tools to process them. And what they get is actually a way to identify the items that are going to, like the similar items that customers bought. we're going to talk about that. That's called market basket analysis or affinity analysis. So we have that. We talk about how you could find similar items. So all in all, data science could make the difference between a giant company failing and becoming bankrupt, or another company becoming quite large. So all in all, so far, let me know if you have any questions. You can send me your questions. I created a Microsoft Teams team that you could use, and feel free to ask me questions in there or send me messages to UR Courses. So I'm going to post the rest of the slides soon, and then we continue from there. Work on your proposals and make sure you create an account in Microsoft Teams using that email that I provided, and also change your name so that we could all communicate more efficiently. If you wanted to meet me, we could meet in Microsoft Teams. We could have one-by-one chat, and we could definitely talk about any topic that you have any problem with. Yeah, again, if you have any questions, send me that question in the UR Courses in Microsoft Teams, and I'll try to get back to you as soon as I can. Okay, thank you very much.